My name is Bob Bateman. I'm the Senior Engineer for the Research and Advanced Engineering Group at the Nissan Technical Centre Europe at Cranfield. NTCE, as we are known, is acting as the lead partner, and we're responsible for delivering one work package looking into developing AD technology, putting it into our development vehicles and testing them on private land first and then on the public road. We're also there to support the other consortium partners in the project. One area that we've spent a lot of time on is the development of the safety case for testing of the AD vehicle on both test track and public roads. Nissan has very strict safety guidelines which we will not compromise in any circumstances, and this has helped HumanDrive contribute to safety standards for all CCAV programs. Finally, there are some key deliverables in HumanDrive which only the OEM can demonstrate on this project. Driving down country lanes with no lane markings, manoeuvring round roundabouts and overtaking of cyclists being the main ones. I have been involved in many UK government-funded consortium projects over the last 10 years, and this one has been the biggest in terms of funding, resource and breadth of consortium partners. However, this has definitely been one of the best managed and overall successful projects delivered. I've seen original deliverables being achieved and lots of additional targets being set and delivered as the project has progressed. HumanDrive has definitely transformed the way AD vehicles are developed, as it has not only incorporated an OEM and Tier 1 supplier, but it has brought in the support of academia and infrastructure to give an overall rounded approach to how AD should be incorporated into the UK traffic management system. First, the chance to manage the work of other partners, whether it is a supplier or university, has been hugely beneficial for us at NTCE. Second, we have set up an AD lab at the Cranfield site where we can work on 3 vehicles at a time if necessary. We've recruited 3 research engineers into the R&AE team and a further 2 skilled technicians to support us on the project. Our research and advanced engineering team is small, but we definitely made an impact with the project, and some of our work has already reached the research out phase back in Japan, and it's looking to be developed into our future vehicle lineups. We've got plenty of other research projects in the pipeline, exploring other areas of the industry, and watch this space for further UK-based connected and autonomous vehicle research from the team. On the technical side, we're showing it can be done. The 230-mile journey from Cranfield to Sunderland is testament to that. With speeds of 60 miles per hour on the motorway and 40 miles per hour on the country lanes, we're showing the capability. Also, through further development of the Hitachi AI and what has been delivered from Leeds and Cranfield universities on passenger and pedestrian perception, we are showing we can deliver something human-like that the customer will want for their vehicle. For example, through working with Leeds University, we've been able to generate profiles of driving that could be considered of high or low risk for a passenger. We also undertook the AD versus AI challenge, asking a series of test drivers to manually drive a defined route through the Cranfield test track, which we recorded on the vehicle. We then asked the participant to become a passenger and subject them to 2 methods of autonomous drive as a blind test. The first was to expose the participant to a number of system-based on-machine learning AI developed in conjunction with Hitachi. Secondly, we exposed the participants to their own driving from the recording at the start, demonstrating in practice how human-like our CAV can be. In my opinion, it's a little too early to put any timescales on this, but what's exciting is that we are being ushered into a truly groundbreaking era of mobility, and human-like drive is proof of that. I believe the capability to deliver the technology is there, but of course there's still some way to go in the development of autonomous drive systems. But it's not just the vehicle that needs to be modified, the infrastructure and regulation needs to be developed in parallel, which we are seeing as part of this project and others. And of course we still have a job to do to showcase the advantages that this technology would provide to our customers, such as increased safety and comfort. This can only be done in small steps, but we already have the building blocks of this technology available in many of our vehicles today. Nissan actually already has around view monitoring and pedestrian detection, and last year it introduced its first generation ProPilot systems, allowing adaptive cruise control and lane departure keep to operate together to give an advanced driving experience. This research project allows us to further the AD journey, introducing the latest technologies, bringing them to the customer at an affordable price. This is all part of Nissan's intelligent mobility, which is Nissan's vision for how cars are driven, powered and integrated into society. Autonomous driving technologies are a core component of Nissan Intelligent Mobility, our strategy for the future of mobility. Nissan is using this strategy to further improve the appeal of its vehicles. and achieve its ultimate goal of a future with zero emissions and zero vehicle fatalities. Through the development of AD technologies, our aim is to allow anyone to travel safely and freely. Our goal is to make cars more convenient and comfortable, as well as to ensure that anyone can experience the joy of driving and travel.